Hi, welcome to How to Repair. Is your heat pump tumble dryer taking a long time to dry the clothes? Is it not getting hot or warm in the drum? Or may not even be collecting water in the collection tray? Well, this video is going to show you how to test and diagnose the problem with your heat pump tumble dryer. And it's a very simple process to do this. You are going to need either two of these single channel temperature gauges, or you could get a dual channel temperature gauge, and this has probes on it that we're going to insert in certain points in the machine to read the temperature. You're also going to need some way of understanding what wattage and ampage is being drawn by the machine, so you understand when the actual compressor is coming on, that it is in the unit. Heat pump tumble dryers use a refrigeration process to dehumidify the air inside the machine to dry the clothes. And it is quite complicated, so you do need the right equipment to be able to test it so you can diagnose the problem. The first thing I like to do is put a magnet on the back of my actual temperature reader and put that on the front of the machine. Now, the two probes have to be inserted, one into the evaporator and the other onto the rear of the machine where the heated airflow comes into the machine. Let me show you where to put this first. Now, I'll bring a picture up of what is behind here. We have the fan motor and we have the ducting unit that goes into the drum. This is where the warm air flows. And what I'm going to do is just loosen these couple of screws approximately in this area. And this will vary from machine to machine depending on which manufacturer you have. And I'm just going to carefully ease back the actual plastic and insert the probe approximately into that position. And then just do the two screws up again. And that is going to measure the high temperature on the actual temperature reader. Now I'm going to plug this in on channel 2, but if you're using two separate gauges, then you just need to know which is the high and which is the low. And if I turn that on, we can see that we have a temperature at the moment of 19.4 inside the machine on that ducting point. Now the other temperature reader we're actually going to put in on the actual evaporator, which is behind the cover here. Now this is a brand new machine, so I'm giving you this for perfect airflow readings. And what I've also done is put some aluminium tape around the probe temperature sensor connected to a piece of wire. This is so I can perfectly slide this in approximately 3 inches into the evaporator. And we'll just drop it in here. And carefully do not damage the fins. And we've got that set up there. We're going to re-put the cover in. And I will thread that round the door and connect that into channel 1. Now you will see a difference in air temperature, because we have 18.8 at the moment on the back one, and we have 15.1 at the front one. Yes, there may be a slight variation in the calibration on the temperature unit, but remember, this is actually touching aluminium, which transfers heat slightly differently to the air temperature at the back. Now, I've also got an additional temperature gauge, and this is only to show you the room temperature in here, and I'll put that on the front. And let me just put something to prop it up so you can see it. And the temperature probe is down here. And so you know it's correct. I'll just put my fingers on it and you can see that the temperature rises straight away. So we've got a room temperature of approximately 19 degrees. This will drop down in a second. I'm going to open the door, and I'm also... You don't need to do this, but I'm just going to put this in to show you the drying capability. These have just spun out of a washing machine and I've weighed them, and they're 1.7 kilo in weight. So I'm just going to put those clothes in there as well. And now what we're going to do is put this on for approximately an hour-long cycle. Now I actually have an old unit out of a heat pump tumble dryer, and I'm going to take the top off just quickly so you understand all the numbers that we're going to be reading during the video. At the front here you have the evaporator. If there was no air going through this machine, it would be exactly the same as your old refrigerator in the house. Inside the fridge it would get exceedingly cold, and on the back of the fridge the radiator would be warm. It is exactly the same process. we have a compressor that will draw a certain amount of load depending on the size of the compressor inside your heat pump tumble dryer. And then we have the main drive motor. The main drive motor blows the air that comes out of the condenser into the machine to evaporate the water in the clothing. This warm, moist air then comes down through the filter at the front of the door and down into the evaporator, where the moisture is cooled and condenses. This water then flows down through the bottom to a pump system that transfers it to the collection tray at the top of the machine. That is the basic process. What we need to understand is the compressor running? Are we getting correct airflows going through the machine? And also, is the water being collected and pumped to the collection tray? Any fault with this system would cause inefficient drying or no water collecting. And we need to understand what the problem is while testing the machine. Okay, we're ready to set the machine up to do the test. And as I said, I will be fast forwarding it. I did make one mistake, by the way. I weighed the clothing and I wrote it down on a piece of paper, and it was 2.7 kilos of clothing that I've put in the machine. Now, we've got the machine set up on this meter. So this is the meter that you need to be looking at. We have a room temperature of approximately 20 degrees. At the moment, our air temperature going from the condenser going into the machine is reading 18.7 degrees, and the evaporator at the front has slightly warmed up, and that's 17.2 degrees. What we're looking for is a differential that will take place after about 10-15 minutes of usage. Now, I must also make you aware that some machines do not have a timed program, and they use a sensor system which is called a moisture sensor. This is a typical moisture sensor, and it measures the actual dampness of the clothing between the two bars using an ohms reading. And this tells the machine that moisture is present, so therefore the compressor would turn on and run. So it will vary the testing procedure from manufacturer to manufacturer, but this test should work on all machines, whether you use a timed program, a preset program or a timed program. So turning the machine on to a timed program, and I'm quickly going to set this up for 1 hour for you, and we will press start. The first thing you will notice is a reading coming up on the actual display here, and it's drawing 220 watts. This also will depend on the size of the motor that's in the machine. And within a minute or so, we will see this increase as the compressor kicks in. Now, I would expect to see 200 to 300 watts additional power coming in when the compressor kicks in. This load will vary over the cycle of the drying time due to the fact that as the gases start working through the compressor, the load changes slightly on the motor, and the motor may have to work harder. So you will see the wattage slightly creep up as we go through the drying process. And I won't fast forward it yet until the compressor kicks in. And then what I'll do is let the video run, but I will fast forward it so you don't have to sit here for an hour. And the compressor just kicked in, and we're drawing at the moment 420, 430 watts of power. So that's 200 for the motor and an additional 200 and something for the compressor. But as I did say, it will increase. Now, we're starting to see differences on temperatures taking place, and at the moment our back temperature is 19.4 and we've got 15.4 on the evaporator. What I'm looking for after about 10-15 minutes is between a 12 and 17 degree variation between the two. This means that the evaporator is getting cold and the condenser is getting hot. We know the compressor is running because we have seen an increase in the actual power being drawn. Now, the machine's been running 10 minutes. You'll notice that the temperature on the heating side has gone up by about 12 degrees, 11, 12 degrees, and the temperature in the condenser has gone down slightly. Now, over the next 5 minutes or so, we are going to see the temperature on the condenser start to rise as the temperature now increases on the actual airflow coming into the machine. Now, as we're achieving 30 degrees at the moment, the moisture is starting to evaporate off the clothing and going down to the condenser, where the water is the evaporator, and the water will be collecting and draining down towards the pump and transferring to the collection tray at the top here. Now, we've just been running for over 15 minutes or so, 16 minutes to be precise. We can see that the air temperature coming into the drum now is 36.8 degrees. And of course, as I said, because the evaporator is fighting to keep it cool, it is rising slightly in temperature. But the differential is approximately 17, 18 degrees at the moment, if I've done my numbers right. Yeah. And over the next 40 minutes, we are going to see the air temperature hopefully get to, with a 20 degree temperature, I would expect to see the air temperature coming into the drum around about 50 degrees, and maybe the evaporator between somewhere hopefully around 20 degrees. And we'll let the machine run now, going through the course of the whole program and while it's drying. Occasionally, by the way, if you are standing in front of the machine, you should hear a pump come on, which is transferring the water in the collection chamber at the back of the machine, and this will be transferring the water up to the collection box. Oh, by the way, you'll notice now that we are pulling 528 watts of power. This is the compressor now working under load, pumping that gas around the system. And of course, we started at 400, so it has gone up nearly 100 watts. And that's not because of any other item drawing power in the machine. That is just the load on the compressor. If you listen closely here, you can hear the pump had just come on, and you would have noticed a slight increase in wattage on the system. Again, you can hear the pump just come on and the wattage drop down. I think the pump is only using about 10-15 watts. We've been running just over 32 minutes on the cycle, and we're pulling just on a 600 load at the moment. Our air temperature now is just coming to 50 degrees. That's entering the drum, so it's evaporating the water very well. And the condenser is working exceedingly hard now, trying to condense that warm, moist air back into a liquid to work as efficiently as it can to collect the water, which then goes down to the pump and up to the collection tray. So we've got 28 minutes to run, and I'll just let it run its full cycle now. But what you did see after 15 minutes, you saw a basically 15-degree differential between the heated air going into the machine and the temperature at the evaporator. And now we are achieving approximately 22 degrees of differential between the two air temperatures. And this is on a brand new machine. These temperatures will vary dramatically depending on room temperature and also the efficiency of the airflow going through the evaporator and the condenser. Okay, we've come to the last 3 minutes on the cycle, and this is just before the compressor disconnects. We have been drawing 650 watts of power, and we have actually got a very, very good differential in temperatures. We actually have achieved nearly 60 degrees going into the drum, and we've got 34 degrees on the evaporator. This is a 25 degree, excuse me, 25 degree differential in temperature, and this means that it's working perfectly efficiently. I would always expect to see a minimum of 15 degrees in differential. If it ever goes below that, you have got serious blockages in the evaporator or the condenser, or you could have low gas in the system, or the compressor is not pumping the gases around the system to achieve the refrigeration process. And in a couple of seconds, we should see the compressor disconnect while it goes into the end of cycle. And we still have a room temperature of approximately 20 degrees. Now, I hope you found this video very helpful. You know, I can try and help where I can at the website. If you want to use the contact us page, you must remember that some manufacturers do not give me the data on their equipment. And the machine has just finished. We've gone down to the last 1 minute. It will do a couple of tumbles in each direction. The pump is coming on, so we can clearly see that the pump is only 7 to 8 watts of power. And that's transferring any excess liquid either to the top or possibly doing a flush at the bottom. The motor, when it's tumbling, is drawing 200 watts. So that allows us to understand that the compressor at the end of the cycle was using 450 watts of power, pumping the refrigerant through the system. And the program just jumped back up to 3 minutes. I imagine that's while it's just doing the end of cycle. But we'll just let this run. While we're letting this run, we have many videos on the website to show you how heat pump tumble dryers work. Also, I've done a couple of controversial videos explaining why I actually do not think we are at the point where heat pump technology is really extremely beneficial because of the lifespan of the machines. And I'll let you form your own opinion once you've watched that video. We've got 2 minutes left on the cycle, and of course the temperatures now are equaling on the temperature at the back and also on the evaporator at the front because the compressor is not running. Anyway, as I was saying, I hope you enjoyed the video. I hope this information allows you to decide whether your compressor was not running or whether you have an airflow blockage. And of course, at the end of the cycle, if I pull this drawer out now, we have only achieved maybe about 1 litre of water has come out the clothing. The machine has just finished, and I'm going to quickly see how dry these are. They're moist. It could do with another 30 minutes really to dry it completely, but I will say, if you just put these over a line or something for 10 minutes, they would dry out completely. But this is with a machine that is working 100% efficiently because it is new. And there we go. I hope you enjoyed the video. Thanks very much indeed for watching. If you have any questions, please leave them in the comments below. I'm going to tell you a couple of quick things that may occur if you have not been getting those sort of temperatures. If you haven't got a differential of 15 to 20 degrees after 15 to 20 minutes of the heat pump tumble dryer working, you either have a refrigeration problem, compressor problem, or the most common is the condenser and the evaporator have got fluff built up in them. If the machine is turning off and you're not getting any water going to the collection tray, you may have blockages in the evaporator or the condenser, or possibly problems with sensors on the machine as well. On this machine, there are 3 NTC sensors. One measures the gas temperatures going through. The other two NTC sensors are, one is at the front behind the panel here, and the other is halfway down the evaporator at the back, and it measures the temperature going through and out. On all Beko machines, I can usually give you the information with regards the NTC sensor values at a certain temperature, because all NTCs will have a value at a certain room temperature. Any other information I can give you? Again, the biggest problem with all heat pump tumble dryers is the dust that builds up. And I just quickly want to look in this filter to see, because this is a new machine and I'd only done one load previously, but I had cleaned it. This is after one load, and that is a fair amount of fluff that has come out of the clothing or the towels. And you must remember, because heat pump tumble dryers normally run 2.5 times longer than a vented tumble dryer, this means that the clothes are tumbling for a much longer period of time, therefore wearing the clothes out a lot quicker, in my opinion. They do say that heat pump tumble dryers, because of the temperatures, do not wear the clothes out, but in my opinion they do. The second filter down here has got quite a bit of fluff in there, and of course there will be fluff getting slowly as there will be fluff getting through to the condenser over a period of time. So I do thoroughly recommend cleaning these on every load, cleaning the second filter every load, and once or twice a month go down into the ducting and on the condenser evaporator and clean that as well. The more dust you can remove from these machines, the better they will work over a long period of time. The other thing I forgot to mention, you will notice as the machine went through the cycle, it didn't do many reverse actions. This means the clothes are always tumbling in one direction. The reason for this is the heat pump tumble dryers basically have one fan that you saw at the back of the machine at the beginning of the video, and this fan has to rotate one direction only for the airflow to go correctly over the evaporator and through the condenser. If it rotated the opposite direction, of course, it will not be driving the air through the system. That's just one thing to point out. So most heat pump tumble dryers do not really do a very good reverse action process to stop the clothes tangling and everything else. Anyway, that's the machine finished with. I hope this information helps you in diagnosing the problem with your machine. Good luck with any repairs that you have, and feel free to use the contact us page on the website if you do need any additional help. Thank you very much indeed for watching. Remember, I buy all these machines out of my own money. They are not sponsored by any of the manufacturers. So if you really want to support the website, you can always click on the Buy Paul a Beer page to support the website. Thanks very much indeed for watching this video. I hope it helped you. And please remember to subscribe to the channel and give the video a thumbs up. Thanks for watching.